Alright, let's talk about angles of elevation and depression. So let's say you're down here on the ground. So this is our ground. You're standing on the ground and you're looking up and you see a plane in the sky. So there's my plane. And you want to know how high that plane is. Well, you have two things here. You have an angle of elevation and an angle of depression. So the way you picture that is your line of sight, so where your eyes are, makes a horizontal line. And then you have a line of where the plane is. And those lines are going to be parallel. So you have this angle that you're looking at right here. So that's the angle of elevation. So we'll call that E. Well, if the plane was looking down at you, because it's down, this angle right here would be the angle of depression. And because those are parallel lines cut by a transversal, those two angles would be congruent. So let's kind of apply this to what we already know, because what you can do is create a right triangle for both of those. And then you can find different lengths. So you could find the distance between you and the plane, you could find the height of the plane, or you could find the distance between you on the ground and as if the plane was on the ground. So, and you can use the trig functions that we did in the previous video to find all of those measurements. So let's go ahead and try and apply this concept. Alright, let's pretend you're 6 feet tall and you want to know how high it is to the top of that water tower. So you're going to look out and see that water tower. And you're a certain distance from that water tower. Let's say you're 50 feet from that water tower. And you measure the angle, and let's say that angle is 40 degrees. And we want to know the height of that tower. So what I have there is I'm trying to find x over here. So what we can do is I have the opposite and the adjacent, so we're going to do the tangent. So the tangent of 40 equals opposite, which is x, over our distance from the water tower, which is 50 feet. So we're going to do 50 tangent 40 to give us the height from our eyes to the height of that tower. Alright, so when I type that in the calculator, I'm just going to round to the it's going to be the nearest hole here, so it's going to be about 42 feet. Oh, I wrote that backwards. So about 42 feet. Well, that's the distance from your eye level to the top of the tower. So you also have to include this distance from the ground to your eye level, which we said was 6 feet. So I'm going to add that 6 to that 42, and the water tower is 48 feet tall. About. Alright, so let's work on a depression one. So I got a helicopter there, kinda, and it wants to land on that landing pad there where that X is. So the helicopter will tell you how high it is in the air. So let's say this helicopter is 200 feet in the air, and we want to know how far it has to travel to get down to that landing pad. And we know that this angle of depression is, let's say, 20 degrees. So it's going to go down at a rate or at an angle of 20 degrees to get to the ground. So you can see that we now have, if we create the ground there, we now have a right triangle. But the angle we have there isn't within that right triangle. And we're trying to find x there. So the distance to the ground. So we have to think of that helicopter making a 90 degree with those invisible planes there. So if I know one angle is 20, 20 minus 90, or 90 minus 20, said that backwards, is 70. So now we have the adjacent and the hypotenuse. So we're going to use cosine. So the cosine of 70 equals adjacent, which is 200 over x. So we multiply by x, we get x cosine of 70 equals 200, and then we're going to divide by the cosine of 70. So x equals 200 divided by the cosine of 70. So type that in the calculator. And when you type that in, you're going to get an answer, and we'll just round to the nearest whole. So that's going to be about 585 feet is the distance going to travel from 200 feet in the air till it gets to the ground. Alright, let's do one more. Let's say we have 2 points here. We'll just call them A and B. And we can connect them. And picture our planes here within this plane. So we got these lines going across. So I got parallel lines there. And if I know the angle of elevation from A to B is 2x plus 10, and I know my angle of depression from B to A is x plus 25. Well, we know that the angle of elevation and the angle of depression are alternate interior angles based on what we just drew. So what you can do to solve for those is to set those equal to each other. So x plus 25 equals 2x plus 10. Subtract x from both sides, you get x. Subtract 10 from both sides, you get 15. Well, that's what x equals. That isn't what the angle measure equals. So you have to put that into the original equations. So you could do 15 plus 25 for the first one equals 2 times 15 minus or plus 10. So 15 plus 25 is 40. 2 times 15 is 30, plus 10 is 40. So both those angles would equal 40 degrees.